Hello, geometry students. I'm so happy to be teaching you again. I'm so proud of you for working hard despite these challenging circumstances that we're under. You guys have been attending class, doing your homework, asking questions, and I'm so proud of you. Today's lesson is going to be 1.4. So again, at the top of your paper, just write the lesson number, 1.4. We're going to be talking about polygons. That sounds kind of intimidating, but we're going to have a pretty simple definition for it. And we're going to be talking about polygons in the context of perimeter and area. So go ahead and write perimeter and area at the top of your notes. Now, for a polygon, I'm sure most of you have heard that word before. There's a few things to note about it. A polygon is made out of segments, so line segments. So we'll just abbreviate that and write the word segments underneath polygon. The other thing I want you to note about a polygon is it is closed, not open, closed. And the final thing is that each segment intersects exactly two other segments, or each side, either way works. Each side intersects exactly two sides. Now, feel free to zoom in, pause, do whatever you need to do to, keep up with the notes here. I know that some of us write faster than others. I'm going to draw a shape on the board, and I'm wondering if you can think about why this figure would not be a polygon. Why would this figure not be a polygon? The reason this figure is not a polygon is it's not just made out of segments. There's a curved component to it. All right, let's try another example. Why is that figure not a polygon? This one is not a polygon because it's open. And then this one I think is the trickiest one. Why is this shape not a polygon? This shape is not a polygon because one segment can touch more than one other one. So, for example, this segment right here is touching four other segments. It's touching this segment here, this segment here, this one here, and that one there. So that could not be a polygon. A typical example of a polygon, this would be no, not a polygon. Examples of figures that might be a polygon, for instance, would be a triangle. This is made completely of segments. It's a closed shape, and each side intersects exactly two other sides. So that's kind of our general definition of a polygon. Now, on your worksheets, they're also going to be using the word convex or concave. Convex is a traditional shape like the triangle that we were looking at before, when no line contains a point in the interior of the polygon. So that's kind of a difficult definition to say. I think it's an easier one to see. So for example, this would be a picture of a convex polygon, because when you draw a line through any side, it doesn't end up going inside the figure. However, I could draw another five-sided figure. Let's draw it like this. This one would not be convex. This would be what's called concave, because if I draw a line through this side right here, it ends up going through the figure. So this figure is convex. This one is concave. All right, fair number of vocabulary there. Let's go ahead and do just a few more. These ones I think you guys have probably heard before, but I'm just going to put it down on your notes so that you have it to reference. We're going to talk about 3, 4, 5, 6, and 7-sided figures and what their names are. If you have a 3-sided figure, that's called a triangle. 3-sided polygon. A 4-sided figure is called a quadrilateral. And again, the spelling doesn't have to be perfect. but there it is if you'd like it. 5-sided figure is a pentagon. Do you know what a 6-sided figure is called? A 6-sided figure is called a hexagon. And then a 7-sided figure is a heptagon. Again, feel free to pause the video as you need in order to get those words down. And I so much look forward to the time when I can see you in person and just hand you out some notes and, you know, have you fill them in. But at this point in time, the notes that I would normally hand out are a little bit too long for videotaping, and so few people have printers at home that really wouldn't make sense to use them anyway. So we're kind of doing a shortened, abbreviated version of the notes that we would normally do. Now, we're going to talk about perimeter and area. We've already discussed perimeter in our previous lessons. It basically means to add up the lengths of all the sides. I just wanted to confirm with you guys what the formulas were for area. So if we look at a triangle, a square, and a rectangle, you should know all 3 of these formulas, but I'd like to just put them down so that you have them all in one spot. Can you remember from, I think it was our very first lesson actually, what the formula is for the area of a triangle? What is the formula for the area of a triangle? If you know that, go ahead and put it here where it says triangle. The formula for the area of a triangle is 1/2 the base times the height. Now, if you're looking at a square and each side of the square is exactly the same length, let's just call it S for side length. The formula for the area of the square, some people think of it as length times width, but because it's a square, the length and the width are the same length. So it's just side times side, or side squared. And then the formula for the area of a rectangle is indeed length times width. So that's kind of like the vocabulary formula section of the notes. Now what I want to do is a couple examples with you guys that are similar to what you might see on the homework. And if you have graph paper, you know, you could do these examples on graph paper. If you don't, just write on the paper that you have. I want to find the perimeter of a quadrilateral where the vertices are A at -3, 0, B at 0, 4, C at 4, 3, and D at 2, -2. Now this would be a perfect time if you have the ability to pause on your device, to pause and make sure you have the points written down correctly. You could also use this time if you wanted to draw an XY axis on your paper. If you have a ruler, great. If not, you know, you should be fine without one. And I would go 4 tick marks out in each direction. Okay, so remember, when we're plotting points, the first one is the X and the second one is the Y. So if point A is at -3, 0, it means I'm going to go 3 to the left and 0 up. If B is at 0, 4, it means I go 0 left or right and then 4 up. C being at 4, 3 means I would be going 4 over and 3 up. And you know what? I think I'm going to label these just so that we have the information here. B is at 0, 4. A is at -3, 0. And then let's see, D is at 2, -2. So I'll put that one here. 2 over and 2 down. Now, if you can, with a ruler or any other straight object. I was working with one student recently who used a Lego brick, totally fine. All right, if we want to find the perimeter, we can't really count out any of these sides because they're not on vertical or horizontal lines. So we are going to use the distance formula. I'm going to use the distance formula to find the length from A to B. And I think I'll do B and C also, from B to C. And then I'll just give you the answers for what CD and DA end up being, just to keep the video kind of, you know, of reasonable length. So I think if we're gonna find the distance from A to B, it might be helpful to label our points. So we'll put an X and Y over the points or under the points wherever you have room. And then little ones on the first one and little twos on the second one. I'm making A be my first point and B might be my second point. And then if you can remember the distance formula, D equals the square root of y2 minus y1 squared plus x2 minus x1 squared. Again, this is a lot of information. Math really does build. So the fact that we talked about in one of our very first lessons, I believe it was 1.1, what it means to put capital A, capital B next to each other. It means distance between. And then in 1.3, we looked at what the distance formula is. So in math, everything that we learned before, we are incorporating as we move forward. All right, so if we're finding the distance from A to B, I want to look at how I've labeled points A and B. So my y2 is 4, so that's going to come first. So we're going to take 4 minus 0 squared plus 0 minus negative 3 squared. I do need to remember that anytime I have two minus signs in a row, it turns into a plus. Oh, this is looking familiar to me. This becomes the square root of 4 squared plus 3 squared, which is the square root of 16 plus 9, or the square root of 25, and then that simplifies down to 5. That's a 3, 4, 5 triangle right there. We could have done that with Pythag if we had wanted. We could have formed a right triangle right here and noticed that this segment was length 3 and this one was 4, so our distance there is 5. That would have been a totally legitimate way for calculating that distance. So that's kind of another option for you. Let's go ahead and do the same thing now, going from B to C. So I'm going to erase the little x and y over point A, and I'm now going to make point B be my first point and point C be my second point. So I'm going to do the distance formula for you guys one more time. All right, again, we're trying to calculate the distance between B and C. So I want to do y2 minus y1. So 3 minus 4 quantity squared plus 4 minus 0 quantity squared. And that works out to negative 1 squared plus 4 squared. Now remember, anytime you square a negative number, it turns into a positive. So this becomes the square root of negative 1 times negative 1, or positive 1 plus 16, which is the square root of 17. Now, because we're going to be finding the perimeter, I personally think it's a lot easier to turn that into a decimal. That is about 4.1. Now, this video could go on for hours if we wanted, but in order to make things a little bit shorter than that, I'm going to give you the length from C to D. Ends up being about 5.4, and from D to A also ends up being about 5.4. So if this problem is asking us to find the perimeter, and let's call this example 1, by the way, if we're trying to find the perimeter of the shape, we need to add up the lengths of all 4 sides. So we're going to add 5 plus 4.1 plus 5.4 plus 5.4. Actually, you probably only need 1 plus sign. When we add all of those up, we get about 19.9. So the perimeter of that figure is 19.9. So that is a lot of work. Some of you are probably thinking, I don't like the distance formula, I don't want to use it. The problem is that this is a formula that we're going to use throughout the year, literally I think in almost every chapter. So it is a formula that you do want to become familiar with and a little bit more comfortable with. It will obviously, of course, also be in your current homework assignment. That being said, as I mentioned earlier, sometimes we have the option to do something other than the distance formula to find the distance between 2 points. We can often use Pythagorean theorem instead. I'm going to do that in our next example. So, for example 2, the instructions say to find the perimeter in the area of square ABCD with vertices A at 0, 2, B at 2, 0, C at 0, -2, and D at -2, 0. So take a moment, go ahead and write those down. And like I said, if you have graph paper, great. If not, you can just draw an XY axis on your paper. In this particular case, we only need 2 tick marks on each axis, going in each direction. If A is at 0, 2, it's going to be 0 over and 2 up. That's A. B is at 2, 0. C at 0, -2. And D is at -2, 0. I'm going to draw our square. Now, the cool thing about the way this figure is set up is we can see it's right on the X and Y axis. And because of that, we can use Pythag to find one of the sides. Once we've found that one side, that will tell us the length of all 4, because remember, we know in a square, all 4 sides are the same. So we can take a look at this right triangle right here and notice that this leg is 2 and this leg is 2. And then we can set up Pythag to find X. So to find the distance, for instance, between A and D, we can say 2 squared plus 2 squared equals, let's just call that side squared. 2 times 2 is 4, so this becomes 4 plus floor, or 8 equals side squared. Then when we take the square root, we get that S equals the square root of 8. However, remember, let's do a factor tree. 8 is 2 times 2 times 2. We talked about this earlier. If you factor 8, 2 goes in 4 times, and then 4 is 2 times 2. So if we want to simplify the square root of 8, first we factor 2 times 2 times 2, then we pull out pairs. So the side length is 2 radical 2. Of course, that is just one side. So to find the perimeter, we are going to take 4 times that. So 4 times 2 radical 2. Now, a lot of students get confused when multiplying in this kind of a situation. You don't have to take the 4 times both of these numbers. You just can go from left to right. So 4 times 2 is 8, and 8 times radical 2 is 8 radical 2. So that would be your perimeter. And then for the area of a square, we know it's side squared. So we're going to say 2 radical 2 squared. Well, that simply means 2 radical 2 times 2 radical 2. You can see why it was important that we learned about radicals earlier this quarter, because we are now using them to solve other problems. And what I like to do here is regroup. So I'm going to put the 2 2's together and the 2 radical 2's together. 2 times 2 is just 4, and radical 2 times radical 2 is a pair of 2's. So I take that out, take that 2 out, multiply it times the 4, and I get 8. So the area is 8. That's a pretty intense problem, but I think it's also a good one because it does prepare us for the chapter later in the book where we do a lot more work with right triangles. All right, that was example 2. We have one last example, and this one's kind of short, and it's not really as calculation heavy as the other ones, but I wanted to do it because there's one like it on your homework assignment, and I felt that it would be easier for you if you saw an example of it first. So we're going to call this example 3. It says a rectangle has vertices 1, 5, 3, 5, and 3, -2. Find the remaining vertex of the triangle. What is the perimeter and area? So let's do that one step at a time. First, we do want to graph the points. By the way, on your homework, I do need you to graph these points. I don't want just the answer. I want to see your work. So let's go 5 up on the y-axis, and then 3 over, 2 back, and let's just say 2 down. Okay, so if we want to plot 1, 5, we're going to put a dot here. 3, 5 is going to be here, and 3, -2 is going to be here. So what I like to do in this kind of a situation is graph what I have and see, okay, what would make sense for the last vertex. We know with a rectangle, the 2 sides opposite each other have to be the same length, and they also have to be parallel to each other. So if we do that, we can kind of see that the other vertex can be right here. Doing so would allow us to have a perfect rectangle. If we count out where that spot is, it is at 1, -2. 1, -2. So the remaining vertex is at 1, -2. Now, when it asks for the perimeter, I'm going to be honest with you, you don't really need to use the distance formula here. You can count using bubbles. The side length here is 2, and the side length here is 1, 2, 3, 4, 5, and then 2 more, 6, 7. So the perimeter is always 2 of the lengths and 2 of the widths, which is 2 times 7 plus 2 times 2. By the way, it doesn't matter which one you call length and which one you call width, which is 14 plus 4, or 18. That would be our perimeter. And then the last thing they're asking us to find is the area. Area, as we mentioned earlier, is length times width. So that would be 2 times 7, or 14. Wow, I am so proud of you if you're still listening to this video, because I know it's been pretty long. Let me see how long it's been. Oh, 23 minutes. All right, you guys have been hanging in there. I'm going to end now, and we'll talk more in Zoom. Bye, guys.